section 4.2. So we're proving triangles are congruent using side, 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 and side, angle, side. So we just talked about how we can prove triangles are congruent in section 4.1, and we had to go through a really long process. We had to show that all three pairs of sides were congruent and all three angles were congruent. That took way too long, so are you with me? So we want to know some shortcuts. So there are several shortcuts throughout this chapter, so you have to know all these by name. Okay, so the first two we're learning are side, 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 and side, angle, side. So it says in the previous section we learned that if all pairs of congruent parts were congruent, then the triangles or whatever figure we had were congruent. So we're going to learn these shortcuts. So in activity number 1, you guys showed that if we had 3 side lengths, there was only one way to create a triangle. And those triangles, all 3 of you guys, or all 4 of you, however many did it, had the same triangle in the end. Okay, so if you have 3 side lengths, so 3 pieces of string, there's only one way to combine those to be a triangle. Now you might have to flip that triangle over. Remember how I took Austin's patty paper and I flipped it over and it fit on top of the other one? You might have to flip it, but it will still be the same triangle. Okay, and in part C we had a problem, and this was because of the triangle inequality. So we had 5 inches along the bottom, but this one was short and stumpy and this one was short, and there was no way to combine those to create a triangle because they didn't match up above that 5-inch segment. Okay, so that was the triangle inequality theorem. So it says if you have 2 sides with A and B, the third side is going to be, it has to be smaller than A plus B. So if I had like 5 and 7, then this third side has to be smaller than 12. Smaller than 12. So it's between 5 plus or A plus B. But then what if our side wasn't, what if I had, I'm trying to say this in a weird way. So what if one of the sides I had was the biggest? What if I had 5 and 7, and 7 was the largest? So 7 is on the bottom, and I had 5. What does this other side have to be at least? It has to be greater than what number? Think about it. 2. Yeah, so it's going to be bigger than B minus A. So it says, for example, if you have 5 and 9, the base, at most, it can't be anything more than, it can't be greater than or equal to 14. It has to be smaller than 14. Does that make sense? So if I had 5 and 9, if I have 14 down here, then if I just had one side that was 5 and one side that was 9, it's not making a triangle, it's just making a flat line. So we need this to be smaller than 14. We need it to be like 13 or 13.5 or something like that. So it has to be smaller than 14. But if 9 was the biggest, then it would be 5, and it has to be at least 4 because of that. So you add the numbers together, 5 and 9 added together make 14, subtract the numbers, 9 minus 5 makes 4. That's how you find the third side of a triangle. Okay, and then activity number 2, so it says use a piece of patty paper to draw a triangle with the following angle, and then the 2 given sides. This one worked really nicely for us. So part A, they definitely matched up on top of each other. So if you have an angle, so we had 20 degrees here, and then we had 3 inches, and we had 4 inches. So if we have an angle between 2 given side lengths, there's only one way to create that triangle, because those are those endpoints, and then we have to connect it, right? So everybody's triangles were congruent when we did that. Okay, so the first one is called the side-side-side congruence postulate. So we just abbreviate this by SSS. So it says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles have to be congruent. They match up perfectly. All the angles then are the same as well. Okay, so it says use the statements and reasons proof to show why this is true. So this is a pretty easy proof. So what were we given at first? We were given that ZW is congruent to, so let's go in the same order. If I had Z and then W, I'm going to do D and then S. And then we were also given that WD is congruent to, so if I do W and then D, I'm going to do S and then Z. So do we see those markings there? They're actually all congruent to each other as well, but we'll just do that. So our reason is because it was given. Okay, so if we can get that third side is congruent, then we're good to go. So is the third side of the triangle. So of this triangle, ZWD, and this triangle DSZ, is their third side congruent, and why? Come on, guys, power through it. You got this. You're acting like it's Monday. It's Wednesday. I know you all stayed up really late doing Math Excel because I checked at like 10:30 and about 2 of you were done. So I see why you're sleepy. So what do we think here? So why can I say this third side is congruent? So here's my triangle. I had this side and this side. They were congruent to this triangle, this side and this side. So what side do we need? We need this side right here for both of those triangles. Okay, so let's look in our original. So if I say ZD, look at the other one. First and then third, I want to say DZ. So it's a little tricky. So I'm going to say ZD is congruent to DZ. And why is that true? Not quite. Yeah, it's not reflexive. I would say symmetric property. Okay, so let's say symmetric. I guess it could be reflexive. That's fine. Or you can say, if you aren't sure, same segment or same side, right? I'd be cool with that too. All right, and then the last thing, so we say triangle ZWD is congruent to triangle DSZ, and the reason is because of the side-side-side congruence postulate. So if you just write side-side-side, that's totally fine. Easy enough? Can we handle that? Easy proof, right? All right, so number 2, so use a paragraph proof. So explain why these are true. All right, I won't make you do the whole paragraph proof here, but let's kind of talk through this. Why do these have to be the same? So I have 8 and I have 10. So if I want to find this measurement, x, I would say x squared plus 8 squared is equal to 10 squared. Do you guys remember my 3, 4, 5 trick? This is a 3, 4, 5 right triangle. It's just not using the numbers 3, 4, and 5. It was using, so 3, 4, and 5. It was using 6, 8, and 10. What do we think the next thing is? So x has to be 6, right? But if you didn't know, then we do 100 equals x squared plus 64. Subtract over, we get 36. So x is indeed 6. So what do we think on the next one if I call that y? 6 squared plus 8 squared equals y squared. What do we think y will be? It will be 10. Amazing. So all 3 sets of sides are congruent. Do you guys agree? So this would be true by side, side, side. I won't make you write out the whole, this is congruent to this, this is congruent to this. All right, so the other one we had was side, angle, side. And the order that we go in is really important. So I said first we have a side, then we have an angle, and then we have a side. So that angle is sandwiched between the 2 sides. That is very, very important. The one that spells out the bad word, which I'm going to write in backwards, SSA, side, side, and then angle, it doesn't work. It doesn't just work because it's a bad word. If I spell it, ASS, it doesn't work because it doesn't work in geometry. So we'll talk about why that one doesn't work. But in this case, if we have a side, then the angle between, and then another side, it does work. Okay, so do you guys see what I mean? So we have the side, the angle between the 2 sides, and then the other side. Okay, so the angle is sandwiched between the 2 congruent sides. Okay, so if you have side, angle, side is congruent to the side, angle, side of the other one, then the 2 triangles are congruent. Okay, so there's these little markings in here. I don't know if you guys can see these if they showed up in your notes, but those are in there. All right, so it says prove that triangle VWZ is congruent to YWX. There's only 4 different steps. This has to be pretty easy. So the first thing is that VW, it's the one with 2 markings, is congruent to YW. And that was given to us. It was drawn in. Our next reason is vertical angles. So what do you think we're going to say for vertical angles? Angle? Yeah, so we could say ZWV, VWZ, doesn't matter. VWZ is congruent to YWX. The reason I did that order is because it was up here. So I just didn't want to think about it, switching it around. So that was by vertical angles. So we have this angle is congruent to this angle. And then we were also given that those 2 sides were congruent. So like WZ is congruent to WZ, WX. We see that? WZ, WX. They have the same markings. That was also given. So what can we say? We're trying to prove that VWZ is congruent to YWX. And our reason for this one is SAS, side angle side. I used to tutor Lucia, and she'd always say SAS by SAS. You can call it SAS if you want, but side angle side is what it stands for. Okay, still making sense? The proofs aren't really that bad. This one, even underneath, you guys see, yes, sometimes it really is that simple. What do you think on number 2? What 3 things do we have marked in? We have 3 sets of sides, right? So how can we say that the triangles are congruent? It's going to be by side, side, side. That's all it is. And all it is for these 4 statements is it's like AB is congruent to FD because it was given. And then it's BC is congruent to DE because that was also given to us. And then it's the last one, AC is congruent to FE, that was the 3rd side, because it was also given to us. So clearly triangle ABC is congruent to triangle FDE by side, side, side. That's all we do. Easiest proof ever, right? All right, so let's try the next one. Okay, do we see why it's going to be congruent? Is it side, 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 or is it side angle side? Side angle side. So what would we go through? We would first do one of the sides, we would then do an angle, then we would do a side, right? Can you guys handle that on your own? We'll skip it. All right, so it says, is there enough information to prove the triangles are congruent? If so, write a congruent statement. So let's decide if these can be congruent or not. So mark in anything that we have to know. So we would have to know those vertical angles are congruent, right? Are they in the order that we want? So we want to have side, angle, and then side. Do we have side, angle, and then side? No, we have side, side, angle. That's the bad one. Side, side, angle. This does not work, so cross it out. So no, not congruent. I know we always write it side, side, angle. Can't be writing bad words in geometry books everywhere. So side, side, angle does not work. All right, the next one. Does this work? Are they congruent? Yes, by side, angle, side. So our congruent statement, it's where it says like this triangle is congruent to this triangle. So we're going to say triangle PQR is congruent to triangle NMO. Like that. Okay, part C. I have some different markings on this one. I have congruent sides. What do those little triangles mean again? What about the lines? They're parallel. Yes, we have parallel lines. So I'm going to write a little note. So whenever you have parallel lines, look for alternate interior angles. Do you guys remember that's like the Z shape? So inside that Z shape, those angles would be congruent. So we're looking for this Z shape. You guys see what I said here? So this Z shape and then this angle is congruent. Okay, so let's look for a Z shape or a backward Z. So we have our parallel line, we have our transversal, we have a parallel line. So this angle and this angle have to be the same. Okay, we already had that congruence mark, we have that congruence mark. So can we get side angle side somehow? Yeah, why? What about FK? Isn't it congruent to itself? It's in both of those triangles. Do we see that? So it's like either reflexive or symmetric. Okay, so we're going to say that triangle. So we got to be kind of careful. So if I go LKF for this triangle, so I go through the 1 segment mark, angle, 2 segment marks. So one tick mark, angle, 2 tick marks. So LKF. I want to go the same order for this next one. So I'm going to go 1 tick mark, angle, 2 tick marks. So I'm going to do G, FK, like that. And it was by side, angle, side. So don't assume if things aren't drawn in, you're not able to. Look for things like parallel lines, look for vertical angles, look for reflexive property. All right, and then we have 3 more of these. Okay, so this next one, what do we think for part D? Side, 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 because we have the reflexive property in there. So yes, by side, side, side. And we're going to say triangle, let's go J, K, M. So I went 1 mark, 3 marks, 2 marks. So let's do 1 mark, 3 mark, 2 marks. So L, M, K. Is that right? That's going to be hard sometimes. How about E? Do I know anything? Nope, so no. And this next one, a little tricky. Tell me why this side does have to be the same as this side. So why are the blue and red equal to each other? It's not really the same. Yeah, segment addition postulate. Did you guys see this? Because we had the little part. The little parts are the same, and the little parts are the same. And then their shared part is the same. So adding those together with the segment addition postulate, these would be the same. So yes, and this will be by side, side, side. And we're going to say triangle FHG is congruent to triangle, what, J, F, H, E, J, L, K. Like that. Okay, does this all make sense? Oh, we have more? Man, I thought I was done. Is that it? I have a whole another page? Man, this is rough. All right, do we understand what we're doing here? Okay, let me see if there's anything else that I want to do. Okay, so let's look at number 6, the very last one. So it says apply the missing reasons for the proof below. So it says given WZ bisects angle XZY. So if it bisects, what does that mean for these 2 angles here? They're congruent, right? So WZ bisects the angle. And then we know that XZ is congruent to, so XZ is congruent to YZ. So we're going to mark that in as well. So that first step was that it was given to us. So how do we know that angle 1 was congruent to angle 2? So I already drew those swoops in. Why did I draw those 2 swoops in? Because I used the word what? Or the phrase bisect. So we're going to say definition of angle bisector. So whenever we have an angle bisector, we draw those 2 congruence marks there. WZ is congruent to itself. That's reflexive property. Therefore, the triangles are congruent to each other. What markings do I have? Do I have side, angle, side, or side, side, side? Side, angle, side. Do you guys see the side, angle, side? And then the last step, so it says the last step's reason was corresponding parts of congruent triangles are congruent. Do we want to write that out? Corresponding parts of congruent triangles are congruent. Can you imagine writing that on all these statements and reasons proofs? It would take forever. So we're trying to prove that XW, this one, is the same as YW. So kind of explain to me in words, not using the CPCTC thing. So why do those have to be congruent if I prove that the triangles are congruent? What's true about congruent triangles? Yeah, all of those pairs of sides are congruent to each other. All of the angles are congruent to each other, right? So once you get that triangles are congruent, then you can say, well, now that I know the triangles are congruent, these pieces are congruent as well, okay? So you get the side, angle, side, you get the side, 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 and then you say, okay, well, all these pieces have to be the same as well. And that's what we call CPCTC. Again, important geometry one. There's a song, it's To Farmer in the Dell. I'm not a good singer. I don't know if I'll sing it to you. We'll see. Sager will. But it stands for corresponding parts of congruent triangles are congruent. So we're going to get to that in the next section, probably. All right, so let's stop there. Sorry, that was